Thank you very much. And for those of you who might be thinking, is science or engineering a good start to a career in politics? I should say that when I studied science at school and at university, I never thought I would end up in the UK Houses of Parliament. And now I sit in our upper house, and our upper house in the UK is called the House of Lords. And we are a revising chamber. So our role, we're not an elected chamber, we're an appointed chamber. And our role is generally not to make legislation, but to take legislation from the House of Commons, the elected chamber, and to look at it very hard and to try and work out whether it's going to make good law. And the interesting thing about being an appointed chamber is that we have all sorts of people in the House of Lords who would probably never have stood for elected office. And so whereas our elected representatives, the House of Commons, we have almost no scientists or engineers or medics, in the House of Lords, we have quite a few scientists, engineers, medics, people from industry. And those people are mostly on what we call the crossbenches, and I'm a crossbencher, which means that we don't sit for any of the political parties. We're completely independent, and we can contribute to legislation and vote exactly as we personally choose on the basis of our conscience and indeed our scientific understanding and knowledge. So I see my role as very much to ensure that our legislation in the UK has really good scientific and engineering understanding underpinning it, because we know that's something that the House of Commons is not very good at. So you may end up in politics, and we desperately need more scientists and engineers in politics. So if that's what you think is exciting, then do think about it. Now, Jean-Marie showed you this picture, and I'm showing you this picture just to remind you that really good ideas sometimes take a long time to happen. So this is one of the first electric cars, and around the 1890s. And of course, the reason why it didn't take off, even though it was faster than the fossil fuel-powered vehicles, it beat them in races, was because we didn't have the high enough energy density in batteries. And it's taken us a century and research like the work that Jean-Marie is doing to get to a position where this is now pretty much a reality. So I want to talk to you about the climate change legislation we have in the UK, and then to move on and spend a little bit of time not talking about energy in that context, but actually talking about transport in that context. So just a reminder that transport is hugely important in terms of CO2 emissions. In the UK now, 20% of our CO2 emissions come from transport. That is the largest contribution of any sector of our economy. It's the biggest single area in terms of contributing to our CO2 emissions. So it is hugely important that we reduce emissions from transport. So in the UK, in 2007, in December 2007, so 10 years ago now, we passed into legislation something called the Climate Change Act. Actually, very similar to what Catherine said about Denmark, this was passed with cross-party support, so all the parties in the House of Commons and the House of Lords as well supported it. And indeed, in the Commons, there were only 3 votes out of 650 against the Climate Change Act. And that has been very good, because at the time we had a Labour government, so that was a socialist government. Our next government was a Liberal Conservative coalition. Since then, we've had another Conservative government, and we've now got a new Conservative government. And all of the governments have supported this act. So it's proved to be a very effective, overarching and continuous piece of legislation to drive us down to reducing our emissions. In the Act, in law, we have a goal for 2050. We have a pathway, which is every 5 years we put into law a new carbon budget. We have a toolkit for delivering that budget, so governments are required to introduce policies to meet the carbon budgets. And we have a monitoring framework. So the Committee on Climate Change exists in legislation, and we have a legislative duty to report every year to Parliament, not to the government, to our Parliament, on how the government is doing in terms of meeting the carbon budgets. So the goal is firmly based in science. Our goal is to reduce our emissions by 80% in the UK compared to a 1990 baseline. Back in 2007, when the Act was being put together, the best advice from the IPCC and others was that meant cutting global emissions by 50%. That meant that by 2050, global emissions needed to be running at about 22 gigatons per year. And the projection was there'd be 9 billion people, so that meant about 2.5 tons per year of emissions each. And if we looked at what that meant for the UK, that meant we had to reduce by 80% because we were a high emissions country. In those days, we thought we would need to reduce the emissions by about half again by 2100. And of course now, since the Paris Agreement, we now know that before 2100, we will have to get to net zero emissions. So we've made the challenge a bit tougher. But at the moment in the UK, we're still working to this 80% goal. And we do it with these carbon budgets. So far, we have passed into law 5 carbon budgets. These blocks are the carbon budgets. And this one here is called the 5th carbon budget. It takes us out to 2032. And the government is in the process of putting in place the legislation to meet the 5th carbon budget. This is the way our emissions have been coming down. So they've been coming down reasonably well. This rather fast slope here is mostly associated with the recession. A good recession is a very good way of reducing emissions, but it's not very good for the people, so I'm not recommending that. And I want to talk quite a lot about how we're going to reach this 5th carbon budget, particularly in the context of transport. So here we are. This was where we were in 2008. These were the things that made up our UK emissions. The biggest chunk in those days was power generation, and then transport, and then heat in buildings and industry. We're not a very agriculturally intensive country in the UK, but actually, as Catherine pointed out, those are, and indeed as Stephen pointed out, those are some of the hardest emissions to reduce. And this is where we have to get down to meet our 2050 objective. And this is how we're doing. Power generation in the last 5 years has been our main contributor to reducing emissions. That red line, that's because we've taken coal out of our power generation system. We've nearly completely eliminated it. We will completely eliminate it by 2025. And we've put in a lot of wind energy. And we've also just in the process of commissioning a new nuclear plant. Industry has been coming down. That's not all been good news. That's partly because some of our industries have been no longer cost competitive, and so we've lost some of our high carbon industries. And one of our challenge areas now is transport, which you can see was coming down, and the recession was very helpful. It reduced traffic quite a lot, but now we've been coming out of the recession, and transport has got itself back onto an increasing trajectory. So we still have a significant challenge in power to get down to the 2030 target on the way to 2050, but we have a very large challenge in transport. Of course, power, as other people have mentioned, is quite easy because governments have to work with a small number of electricity generators. Transport is much more difficult because the government has to work with every member of the population who moves anywhere, who has a car, who takes a bus, who uses a train. Dealing with 6 electricity companies versus dealing with 62 million people means, from a policy perspective, transport is a much more difficult and intractable problem. So this is our 5th carbon budget to take us out to 2032, in fact, and it has, of course, 2 elements of analysis and policy, one of which is what's going to happen to demand for transport. So we need to do everything we can to reduce demand, but we've got a growing population, we've got growing wealth, or the government always hopes we have growing wealth, and we have growing trade. All of those will be driving more transport. We need to be trying to reduce the demand, but even with our assumptions for improving logistics efficiency and getting a 5% modal shift to people walking and using their bikes, we still see we're going to have to cope with a 15% increase in demand by 2030. And the other part of it, of course, is that we've got to make the fleet less CO2 intensive. So we need to reduce the CO2 intensity of cars by 56%, vans by 57%, and heavy goods vehicles by 46%. And we see a small contribution of that coming from an increased use of biofuels, a modest contribution to that coming from improving conventional internal combustion engines, and a significant chunk of that coming from 60% of our new car fleet being electric by 2030. And those are the challenges that the government has to put policies in place to meet. And these are the kinds of policies we have. At the moment, we have financial support for the purchase of electric vehicles because they're more expensive than conventional ones. And we're just in the process of developing the strategy for the charging infrastructure that's going to be needed. We've got the EU emissions targets, and that's one of my anxieties as UK has decided to leave the EU, that we need to maintain commitment to the EU vehicle emission targets or put in place some even stronger UK targets, possibly. And we've got the the renewable transport fuel obligation to increase the sustainable biofuels in our remaining fossil fuel mix by 2030. But this is where the emissions currently come, the CO2 emissions currently come from vehicles in the UK, from road transport. And you can see that actually 73%, a huge majority of that, comes from what we call light-duty vehicles, which are cars and vans. So the policy focus in the UK has been very strongly on tackling this area first. And I think you can understand the reason for that. So what are the kind of policy issues that we need to think about? And of course, what's the sort of science and technology that needs to back those up to make sure that really sensible decisions are made? Well, first of all, we need energy for transport. And if we're going to make that electrical energy, as both Stephen and Jean-Marie pointed out, we need to know what the emissions intensity of our electricity generation is. And we also need to make sure we've got enough electricity generation. And as Stephen also mentioned, we need an increasingly clever electricity grid. We need to make sure the right kind of vehicles are available for people to buy. We need to make sure there's a charging infrastructure so people feel confident about it. And we need to make sure that consumers can afford them, feel confident, and feel they've got plenty of choice. So let's look at the first one of those. And this is the challenge that people in the UK often say is impossible. It's one of the things you have to counter, because they say, right, this is how much energy we use per day for the last 3 or 4 years. And this red line at the bottom is electricity generation. This blue one, we use a lot of gas in heating in the UK. And you can see winter and summer, the amount of gas we use is very variable. But you can see transport fuels is this thin grey line along the top here. And what you can see is that if we were simply to convert the amount of transport fuel by energy that we use to electricity, it looks as if that's about double the amount of electricity. So it looks as if we would have to expand our electricity system by 2030 to 3 times the scale it is today. And that sounds like an impossible challenge, and also a very expensive challenge. However, there's something wrong with this diagram. And this tells you what it is, which is that is the fuel that vehicles consume, and that is the electricity that we generate. And most internal combustion engines are only about 30% efficient. So the energy those vehicles are consuming is 70% less than that. And most electric motors are something like 90% efficient. So if we assume our electric vehicles are 80% efficient, then we could replace all of that transport fuel by this much electricity. And some of that transport fuel, kerosene, is used in aviation. And at the moment, we're not trying to make aircraft electric, although there's an interesting challenge, I think, for your generation. We're probably not trying to make all of our biggest HGVs, biggest heavy goods vehicles electric, because we probably couldn't do that with batteries. So there's another challenge we're leaving for you. But we could probably replace quite a lot of the car fleet. So at most, that's the amount of electricity we'd need. And actually, it's considerably below that. But it's one of the things, of course, in policy we have to be thinking about, because as Catherine said, it's a system. We can't look at cars without looking at the energy system as a whole. So actually, by 2050, we think we probably need overall in our economy about 40% more electricity generation than we have today. But in thinking about how much electricity we're going to need for cars, we also need to think about, well, how much do people drive every day? And this actually tells you where the emissions come from driving in the UK today. But what you can see, I think, is that most of our daily journeys in the UK are under 25 miles. There's a huge peak here. And in fact, we have an average daily driving distance that's pretty much the same across Europe and in the USA, which is something between 25 and 30 miles per day. So it's pretty consistent, and we therefore need to think that's the amount of energy people use for their personal commuting every day. We also know that in the UK, as Stephen mentioned, in the UK we use more electricity during the daytime than we do at night, and we use more electricity in winter because it's colder than we do in the summer, because most of us don't have air conditioning, fortunately. And if we think about how much electricity there is available during the nighttime dip, so this is night, this is day, this is pretty much the nighttime dip, then there are about 8 hours when there's about 16 gigawatts of capacity available, which is 0.13 terawatt hours. People are driving a daily driving distance of 30 miles. That would use about 9 kilowatt hours of energy. So actually, if we could persuade everybody to plug their electric car in at night, we could charge 15 million electric cars using that energy that we could be generating with our current system overnight. And actually, there are about 30 million cars in the UK. So in an ideal world, if we could get everybody to behave exactly as we would like them to behave and only charge their cars at night, we could actually charge half of the UK car fleet with energy that is available overnight in the UK today. Kind of makes the problem shrink a bit. And it also kind of gives you some insight into why we need an intelligent grid, and why, as I think Stephen Chu said, once we have artificial intelligence that is able to understand our behavior patterns, understand when we plug our vehicles in, understand and model the way millions of us use electricity in our homes and in our businesses, we can probably get away with very little additional generating capacity from the sort of levels we have today. But that just gives you a kind of... And the other thing, of course, we're moving to a lot of offshore wind energy in the UK. We now have the largest installed base of offshore wind in the world. And the wind tends to blow around the north of the UK more strongly at night than it does during the day. And that's another reason why it would be a very good idea to have lots of people with electric cars plugged in, because they could make use of all of this really low carbon offshore wind energy. And this is something that picks up on something that both Jean-Marie and Stephen referred to, which is the emissions from electric cars. Oops, sorry about that. This line represents, if we take into account the production of the emissions from the production of the fuel, that represents probably the best internal combustion engine, which is probably somewhere around 80 grams per kilometre of CO2. That represents probably an average car on the UK road today, internal combustion engine, in terms of its emissions. This is the carbon intensity of the electricity we generate. And back in 2010, our electricity generation in the UK was at almost 500 grams of CO2 per kilowatt hour. So an electric vehicle would have been, this red line, would have been slightly worse than the very best internal combustion engine car, but a bit better than a Toyota Prius, which in those days came in about where this green line is. They've got better since then, I should add, for Toyota protest. This is where, in our fifth carbon budget, we need to be, I can't remember, our third carbon budget, we need to be by 2020. And this is where, in our fifth carbon budget, we need to be by 2030. And so you can see how dramatically the emissions from an electric vehicle improve as we decarbonize our electricity system. And so again, it emphasizes that we have to think as a system. We have to have a low-carbon electricity system, as I think Jean-Marie pointed out, to get the benefits of the battery electric cars that are going to have his great new batteries in them. And it's also why at the moment in the UK, we're looking at but one of the reasons why we're looking at battery electric as being better than hydrogen. If you make hydrogen by electrolysis, then again, as you decarbonize your electricity system, your hydrogen vehicles get better. But until you get to really low carbon intensities in your electricity system, the battery electric is considerably better in terms of CO2 emissions than hydrogen. So that, I think, picks up on some of the things that people have said. The other thing, of course, you need is that there are vehicles available. And this is a slide from Bloomberg showing the kind of model range we shall have by the time we get into next year and the year beyond. And you can see, as battery technology has improved, you can see very importantly, I need to press the right button, that we at the moment, we have a lot of vehicles that are in this up to kind of 200, 250 kilometer, 150 mile range. We're starting to see, with Elon Musk driving it very hard, these vehicles appearing in this range up to sort of 500 kilometers, 350 miles. And really, it's when we have lots of vehicles available at a reasonable price in this range that we're really going to start, I think, to see this market pick up. But the things that have been helping to drive this have been the EU vehicle emissions targets. They've been very important. And as I say, I have a real concern on leaving the EU that the UK needs to hang on to those targets very, very tightly. We've also had the drive of our fifth carbon budget target of 60% new cars being electric by 2030. And we now have new policy published this year called the UK Clean Growth Plan, and that has committed, the government has committed that there will be no new conventionally fueled, so no petrol or diesel fueled cars and vans by 2040. They will all have to be electric or electric hybrid. So those things are, in the UK, are certainly driving this move for people to be looking at all of those new electric models. So if people are all going to have these electric cars, how are they going to be able to charge them? And it's all very well if you've got a house with a garden or an area outside and you can plug your car in at night, but not everybody's going to be able to do that. And the people who can afford these cars first probably live in cities, and they're probably less likely to have a garden or a space to park. So we need charging infrastructure. And so that's an area where we're currently in the UK developing policy with some kind of some time pressure, really. We're in the process of thinking what policy do we need and how do we implement it. We know that we will need both slow and fast charging. We'll need to understand the types of journeys people are making. We'll know that we're going to have people who've bought vehicles with quite a wide range of battery range, so we've got to be able to take that into account. we've got to take people's behavior into account. Some people are anxious and will want to plug their car in a lot of the time. Some people will be more confident and will be happy to run their battery right down till it's nearly flat. And people are not going to be wanting on a motorway to be queuing for a long time for somebody else who's charging their vehicle at maybe the only electric vehicle charging point. So we've been doing a modelling project on the Committee on Climate Change. We've been modelling both what we call our strategic road network and looking at the journeys people make, the frequency with which they make those journeys, the lengths of those journeys, the affluence of the areas which the people come from, and therefore the likelihood that they will have bought particular types of electric vehicle. And we've been looking at, to get to 2030, what kind of infrastructure do we need to get in place? And the conclusions, which we're publishing later this month, the conclusions say that on our strategic and motorway road network for long-distance journeys, we've currently got 460 electric vehicle chargers, and by 2030 we'll need nearly 3 times that number. And that our model suggests you might have to wait for up to 12 minutes to charge your vehicle at those chargers. But it's quite interesting because we will have seen 2 orders of magnitude increase in the number of electric vehicles, but we only pretty much need to double the number of chargers on our strategic road network. Now, we have to make behavioral assumptions, so we have the advice of social scientists who study human behavior. I think we've assumed for this modeling that actually when you start your journey, if you're going on a long journey, you're very likely to start with your battery fully charged, and that you will go for the minimum number of stops on your journey in order to charge your vehicle. You will want it, obviously, to be charged using a fast charger, so you don't have to wait too long. And we've decided on advice that you might be tolerant of waiting 12 minutes to use that. And so that's quite interesting. And part of what drives that is, of course, that over that period to 2030, batteries will continue to get cheaper, and their capacity and their energy densities will continue to improve. And so actually, if you take our modeling out to longer times, what you actually see is you go up to a maximum number of chargers needed on the network, and then vehicle battery capacity gets greater, and actually the number of chargers you need probably starts to decrease again, actually quite quickly. The problem with that is, you then have to think, well, what's the business model for anybody installing a charger? And you rapidly come to the conclusion that these chargers are probably never going to make any money. So there is going to need to be policy associated with probably some kind of requirement or some kind of government subsidy to ensure these chargers are installed. So those are the kind of questions in the policy space that we're asking at the moment, the kind of thinking that's going on. And if we look at short journeys as well, we make different assumptions for short journeys. We assume people on short journeys to the supermarket or taking kids to school or going shopping or visiting friends, that they will probably plug in wherever they can and charge for a few minutes if there's a charger available. So our assumptions are that for local chargers, we will want to see that network expand rather more quickly. So maybe a factor of 10 against a factor of 100 increase in cars. But also, looking at that, it suggests the business model for local chargers is rather better, and they do look like things that you will be able to make money out of. So actually, the market will probably deliver those quite effectively, but it won't deliver the ones on the strategic road network. So then we come to customers. That's us. That's those 62 million people who have to do what the government would like them to do. And we've touched on model availability, and that seems to be coming. What we haven't yet touched on is something that previous speakers have already highlighted, is this issue about battery costs and range. And Stephen Chu showed a very similar diagram to the one I'm going to show you. Oh. Where's my battery cost diagram gone? Sorry, I've got them in the wrong order. In doing our projections, in doing our modeling for what sort of scenarios we should have for the fifth carbon budget, we've had to assume how battery costs were going to come down. And we were doing the work in 2014, and we assumed battery costs would decrease in this way, in this green band here. Actually, battery costs have followed this blue line. They were coming down along there. And then all of a sudden, they started to come down very, very quickly indeed. And we now see that whereas we assumed that we might get down to $200 per kilowatt hour for a battery pack, many of the projections, as Stephen Chu showed us, are now that they will come down to somewhere around 100 or perhaps 150, but about half of the assumption that we made. So that actually makes all of our assumptions in the fifth carbon budget about electric vehicles, makes them all rather more cost effective than we thought they were going to be. And let me just give you a sense of the type of modeling that we do. We model the impact of battery cost from both a consumer and a government perspective. And from the government perspective, we look at the cost effectiveness or the abatement, the CO2 abatement cost. This is a battery electric vehicle. That's a plug-in hybrid electric vehicle. Let's just concentrate on the green one. We look at the abatement cost from a government perspective in terms of the carbon price at pounds per tonne of CO2. And we thought battery prices were going to be, by 2030, were going to be around $200 per kilowatt hour. Actually, they seem to be, according to the chart, round about that level already in 2017, and they seem to be coming down to about $100 per kilowatt hour by 2030. That would suggest that certainly by 2030, there will be zero abatement cost, in fact, a negative abatement cost from a government perspective. So we wouldn't need a carbon price in order to be able to justify the abatement from battery electric vehicles. But it also suggests that something rather interesting ought to be happening about now, because from a government perspective, these become, if you like, a no-brainer. They come down to an area where they don't cost, there's no additional abatement cost. From a consumer perspective, and again, let's concentrate on the battery electric vehicles. We assumed at this point in 2017 that we'd be paying $390 per kilowatt hour for the battery pack. And from a consumer perspective, just about now, that seemed to become a logical, cost-effective investment to make in an electric vehicle from a net present cost point of view, looking at the upfront cost of the vehicle, the high upfront cost, but also the low cost of ownership for the vehicle. So round about now, government should be seeing that it should be able to start to phase out the subsidy that it is currently paying people in the UK to get them to buy electric vehicles. In fact, I suspect that consumers aren't quite as logical as this. They don't look at the long-term cost of their vehicle to run, so we will need the subsidy for a bit longer. But it does say we're kind of almost at that turning point where battery electric vehicles become cheaper to run than conventional petrol vehicles. And interestingly, there was a new paper published in Applied Energy last month that actually says that in the UK, the US, and Japan, electric vehicles with the government subsidy are now cheaper to run than petrol or diesel vehicles. So I think we've come to almost a turning point for vehicles where we will start to see people's behavior and people's purchasing decisions change. So battery costs are coming down, lots of important new technology developments, and very exciting to hear from Jean-Marie about all the more exciting developments that are to come in the future. We've got policy in the way of support for purchase, and we've got to find out how do we phase that out. We're looking at policy in the UK about how do we make sure the charging infrastructure is in place. And we really have seen, I think, the targets like the EU target driving model availability to address the issues that consumers will have. So we've talked about that one. And so here's my conclusion slide. You'll be glad to know I've got to the end. And the conclusion slide says, in our fifth carbon budget, we have a prediction which is that electric vehicle sales in the UK, to meet our target, need to follow this red line. And up until last year, they followed this blue line, and we were getting just a bit worried that they were falling slightly below our indicator. But last month, in the UK, electric vehicle sales were up 37%, and the sales of conventional diesel vehicles were down 30%. And the predictions that were published last month by the Energy and Climate Change Intelligence Unit say that if the trend that we've seen over 2017 goes on, in 2019 we will be selling more electric vehicles in the UK than we sell diesel vehicles. And indeed, last month, non-conventionally fueled vehicles, which the predominant chunk of is electric vehicles, reached 5% of UK vehicle sales. 5%. The Chinese have a target of 10% by 2020. That's much more aggressive than the UK target. But we've reached 5% last month. So I think we are genuinely seeing that the policies we have in place to support electric vehicle ownership in the UK are starting to be effective. We've still got a huge challenge in transport. We've still got to get the infrastructure in place. The job certainly isn't done. But it's a very exciting area to work in, bringing the science, bringing judgments on when new technologies are going to be available, how do you persuade people to take them up, bringing all of that into thinking about what kind of government policies governments should be implementing. And let me encourage you, as you set out on your careers, to think that maybe that's the direction you'd be interested in going in, because it's very important that in all of our civil services and in all of our parliaments, we have more scientists and engineers. Thank you very much.